In our next section on the IPS, we're going to look at running multiple virtual sensors with different signature policies when we are running the inline VLAN pairing. Where with our previous example, we had the IPS on VLAN 125, that as traffic is moving from ASA2 to router 5 and vice versa, that was being sent to the virtual sensor 0, which was assigned the signature 0 set. In addition to this, we're also going to put another sensor on the segment between router 3 and router 4. We'll say that this is virtual sensor 1. That is going to use a separate set of signatures. We'll say that this will be signature definition 1. That then can have different custom signatures or different enabled or disabled signatures based upon exactly what we're trying to protect. So similar to the ASA where we can have the multiple contexts, we're essentially taking the one physical box of the IPS and then splitting it into multiple logical devices. Now, in order to do this, just like we did with the last example in the inline VLAN pairing, we now need to separate router 3 and router 4 into two separate segments. Where previously the traffic from 3 to 4 was using VLAN 34, we need to now split this into two different segments. We'll say that this is VLAN 30 on the connection to router 3, and then VLAN 40 on the connection to router 4. Now, we already have the sensor on the switches configured as a trunk. So really the only thing that I need to do is go to the switch that is connecting to router 4, which is switch 1. Let's say show run interface fast Ethernet 4. I'm going to put this in VLAN 40. So we'll say switchboard access VLAN 40. Then I also need to make sure both of these are created. So VLAN 30 and 40. Then on the connection to router 3, which is switch 2's port fast Ethernet 3, I'm going to put this one in VLAN 30. Switchboard access VLAN 30. And both of the switches know about both of the VLANs. Now, eventually, when we look at the show interface fast Ethernet 10 trunk, which is the link that is going to the sensor, I eventually will see VLAN 30 and 40 forwarding onto the interface. Now, typically when you do this from a real design point of view, I wouldn't want all of the VLANs going to the sensor, because really we're only using VLANs 125 and 555 for the pairing between router 5 and ASA2, and then VLANs 30 and 40 for this particular pairing. So to cut down on the amount of traffic, it would normally be a good idea to go to the trunk link and then limit the number of VLANs. So we'll say switchboard trunk allowed is VLANs 30, 40, 125, and 555. So two separate pairings, where 30 and 40, this is routers 3 and 4, and 125 and 555, this is router 5 and the ASA. Next, if we go to the IDM, under the signatures, so we have signature definitions for SIG0. I'm going to clone, or basically copy, the previous definition of signatures. We'll say that this is SIG1. Then under the virtual sensors, I'm going to add a new one. We'll call this VS1. The description will be the, let's say, R3 to R4 virtual sensor. Actually, VS1 I wanted to name it, not VS2. That's okay. So this is virtual sensor 2. Then under the VLAN pairing, we're going to add a new pairing that is on the same interface, because we only have one physical link. We'll say this is subinterface 2 that is pairing between VLANs 30 and 40. This is the R3 to R4 pairing. where then if we go back to the virtual sensor, I want this one applied to that second pairing. So again, similar to the context, we now have two different sensors internally that have, let's see, they're both actually assigned the same signature policy, which I'm going to need to change this. I would say I want signature policy 1 for the second sensor. Then I could add new event action rules or new anomaly detection. Really depends on how granular I want to be for this new policy. Now, since the signature definition 1, sig1, was copied from sig0, what we should see is that once the traffic is transiting from 3 to 4, we will have the same monitoring policy as we did before, which means that the ICMP echoes should be generating the alerts, and that custom signature where we were deleting the flash, that should also be used to block the connection pair inline. So if we were to now go to the sensor, and we're still looking at the show event alerts, then if we were to go to router 3 and ping router 4, we should see that the alert is generated, which it is. So I now know that the pairing between router 3 and 4 is properly working. If I were to go to router 3 and telnet to 4, and then say delete flash, ideally we would want this signature to trigger as well. So let's go back to the IDM and let's see if that custom signature actually got copied from sig0 to sig1. So now under signature policies, signature definitions, notice that we have the sig1 as well. We do have 60,000, where 60,000 says again, string TCP, we're going to deny the attacker service pair inline and produce an alert if delete flash is heard for port number 23, and we're going towards the service. So let's try that again from the other side. Let's go to 4. And from router 4, we'll telnet out to 3. So now this connection is dropped. If we look at the IPS, it says that the attacker was 4, the victim was 3. The result is that we denied the attacker service pair inline. And let's try this again from the other direction. From 3, let's telnet to 4. Then we'll say delete flash. So it is actually working. It's just that it took some while to apply the new signature policy. Sometimes you'll see with this platform, especially some of the older ones, like we have here, which is the 4235, you may see that sometimes the signatures don't work exactly as you want. A lot of the times, if you simply disable the signature and then re-enable it, or as a worst case scenario, reboot, that you don't want to exclude that from your troubleshooting process. So it should happen in both directions, that the signature is being triggered. But let's say now for this particular policy, we want a more granular signature where maybe router 4 is running a web service and we want to filter the specific URLs that the test PC is able to access. So it's going to be just like the application inspection on the ASA or on the iOS, where we can look at those individual fields like the HTTP methods or the HTTP URI and look for different strings in the header or body. And then based on that, we can perform our different actions. But the key now is that since we have two different signature engines, I could apply a new custom signature under sig1 that is not going to affect the traffic that is between router 5 and ASA 2. So in sig1, let's go now through the the custom signature wizard, where we'll say this is going to be under the service HTTP, where we have signature name, let's say reset on specific URL, where we want to see what is the URI regular expression. So this is going to be whatever is in the actual header of the packet. So right now, as a placeholder, I'll just say that this is the URL string. Then once this happens, actually I need to say the service ports as well. So this is on port 80. And what do I want to do once this is triggered? So I'm going to produce an alert. Let's say produce verbose alert. We'll look at the more detailed one. Then I am going to, let's say, deny the packet inline. So we're not deleting the ability, or we're not removing the ability for the sender to start new sessions. It's basically just dropping that individual packet. Now to test this, I'm going to configure router 4 as a web server. So this is running the web process. And then the test PC is going to be the web client. So on router 4, in global config, we'll simply say IP HTTP server. We already have the username Cisco and password Cisco that we can use for authentication. If we go to the test PC and browse to that server, let's say to 172.16.4.4. From here we can get to the GUI management of router 4. Now we looked at some cases before of this on the ASA and the iOS where we're looking for specific strings. And one way that I can do this is by issuing a command, let's say a command at level 15, where I say show IP route. And the way that the syntax format works is that this string is passed to the router inside the URI or the URL, where if I were to take this full string, this is going to be whatever command that I want to issue. So if I say show IP route, if I say show IP interface / brief, it's going to run whatever this command is. But let's say I want the IPS to listen for when someone is saying show IP route, and they're going to drop that connection. So where specifically this is going to be in the URI /show /IP /route/. So from the IDM, I'm going to go back to this particular signature, and we'll specify that this is the URL string. If we go back to the IPS's command line, we're looking at the show event alert. This is going to show our verbose alert, assuming that the regular expression is correct. Then from the test PC, if we say show IP, let's say show IP Ceph. So this one is fine. If we then say show IP route, we can see the payload of the web packet. The sensor says that this attacker went to the victim at port 80 and was triggering the signature reset on the specific URL. The result of that is that the packet is denied. Now, this doesn't mean that I cannot connect to router 4 at all. It just means that that individual packet flow was dropped. So it's a little bit different than resetting the TCP session like we saw before. Simply the packet is discarded and the IPS sensor is not telling the attacker that there was an issue with it. So the key with this is that when we're doing multiple different signature definitions or multiple event action rules or the anomaly detection, we can apply these to different virtual sensors. Then, depending on whether we have multiple physical interfaces or multiple inline VLAN pairs, we can put the one physical sensor in multiple logical portions of the network at the same time in order to have multiple separate policies.